Here is a single binary digit, and we see how it represents 0 and 1. The question is, how can we get it to represent -1 or a negative number? How about we use a minus sign, just like we write on paper? Well, that's great for human beings when they're writing on paper or on a whiteboard or something, but it doesn't really work in digital electronics because I don't know where I would put an actual physical minus sign, a human readable minus sign. So then maybe we can ask, is there a way for us to use binary to represent negative? Well, in fact, why don't we actually just add an extra bit and we'll use that to represent the minus sign. With that extra bit in place, we can now count from +1 to 0 to -1. And then we can count back up from -1 to 0 to +1. We're able to represent -1 by using that new bit that we added. When that bit is 1, it's a negative number, and when that bit is 0, it's a positive number. That sign bit, which is that new bit that we added, is used only to represent positive or negative. The remaining bits, and there's only one remaining bit in this case, is used to represent the number. If that remaining bit is 0, the number is 0. If that remaining bit is 1, the value is 1. And whether it's +1 or -1 is dependent on the sign bit. This method of encoding the sign for an integer in the high bit is generally referred to as 2's complement. And we can extend this out to 1 byte, where the highest bit in the byte is the sign bit. When that sign bit is 0, the number is positive. When that sign bit is 1, the number is negative. By adding more bits, we can now represent higher positive values and lower negative values. Let's go through some of the values here so you can see some interesting characteristics with a 1 byte signed integer. Let's start by counting from 0 to 15 and back from 15 down to 0. And as we can see, it's pretty much the same as the way it was before without there being any sign bit. However, even though we don't see any difference when we're counting like this, it's important to remember that the other bits still do have meaning, especially in this case, the sign bit. The sign bit being 0 actually means that we're counting from 0 to 15 and from 15 back down to 0. If the sign bit were 1, we would be doing something different than counting from 0 to +15. All right, now let's take the important step of going from 0 to -1 and let's see what happens. Wow, okay, what just happened here? If you notice, all the bits turn to 1, and that is -1 in 2's complement form. Now, how did we get here? Well, first let's explain this in human terms.